Hello students, this is Dr. Sourav sir's class and I am going to solve a question which appeared in the UPSC Mathematics Optional Paper 1, and the question tells us find the equation of the right circular cylinder which passes through the circle which is in the intersection of those figures, which are a sphere x square plus y square plus z square equal to 9 and a plane x minus y plus z equals to 3. Now we are going to find the equation of a right circular cylinder which passes through a given circle. Now we have to identify the center and the radius of the given sphere first. So the equation of the sphere is this, and we can easily see that the center of the sphere is this. And as we can rewrite this on this form, in this form, so the radius of our this sphere will be 3. Okay. Now the intersection of this plane with the sphere defines the circle. So the equation of the sphere represents this and radius is 3. Now the distance from origin to the plane x minus y plus z equals to 3. How can we write that? We can write this in this form. Let d be the distance and it will be calculated by 0 minus, here will be 0 and this will be minus 3. We have to find the distance from origin to this plane. So the x, y, z will be 0 here, and then there will be, as the coefficient of x will be 1 as 1, so there are these things happen. This thing happens. Okay. So the distance will be now 3 by root 3 and it will be root 3. Okay. Since the radius of the sphere is 3, the radius r of the circle where the plane intersects the sphere can be calculated using the Pythagorean theorem. So, using Pythagorean theorem, we can say that radius r equals to 3 square minus root 3 whole square, and it will be root over 9 minus 3, and which is equals to root 6. Okay, now we have to determine the direction of the cylinder's axis. So the axis of the right circular cylinder must be perpendicular to the plane of the circle. I am repeating that. The axis of the right circular cylinder must be perpendicular to the plane of the circle. Since the plane of the circle is given by x minus y plus z equals to 3, then the normal vector to the plane is n equals to 1 minus 1 and 1, the coefficients of x, y and z. Thus, the axis of the cylinder is parallel to this. Now, we have to write the equation of the cylinder. So, a right circular cylinder whose axis is this, whose axis in this in this direction n, in this direction of the normal vector, can be described by requiring the distance from any point xyz on the circle, on the cylinder, to the line defined by the axis is constant and equal to the radius of the circle root 6. Okay, so we have to calculate the distance first in this case also with the directional vector 1 minus 1 and 1. So how can we find it? We can find it by this form. It will be, this is cross product and there this thing will occur. Now we have to calculate the cross product first. The cross product will happen in this condition will be equals to I, J and K. Here will appear X, Y, Z, and there will be 1 minus 1 and 1. So it is equals to Y plus Z. There will be iota. As Y into 1 equals to Y and minus of minus Z will be plus Z. So similarly, it will be X minus Z J plus, then what will occur? Then will minus X minus Y K. Okay, this is our cross product. And we have to find the magnitude of this vector. Now, the magnitude of this aforesaid thing is equals to this form. Okay, now by the problem, we appear to the final condition, which is, okay, firstly let us call it P. Say P. Now, by the problem, we appeared at this form. P by root 3 is equals to root 6. As I said that will be equal to the radius of the circle. So what is the radius of the circle? The radius of the circle is root 6. So P by root 3 is equals to root 6. Then P will be root 18 and P square is equals to 18. So what is P? P is this. Then the equation which is required for the right circular cylinder will be this. This is the required answer for the question. Hope you understood. Thank you guys.